Hello everyone and welcome to DevDive. This is an introductory video for the new series Deep Dive into Hibernate and JPA. We'll be covering all aspects of this technology and how to use it effectively to build high quality applications following of course the best practices. So as I said in this video, we're going to talk about persistence and the problem Hibernate is trying to solve. Alright, let's dive in right after the intro video. To get started, persistence is one of the fundamental concepts in application development. If an information system didn't preserve data when it was powered off, the system would be of a little practical use. So to keep it simple, persistence means that our objects can be saved and brought back later, even after the program has closed, so that we can restore our application state, and obviously users still gonna consume our services without noticing any loss of their information. When you work with a SQL database in Java application, you issue SQL statements to the database via the Java Database Connectivity API, which is a specification that allows Java programs to access database management systems like Oracle, MySQL, and PostgreSQL. And whenever we want to interact with a specific database, we're going to load a JDBC driver, which is the implementation of these interfaces provided by this specification. In this example, the provided SQL query retrieved journal entries from a table named journal entries based on certain criteria. As you can see, we use JDBC API to bind arguments when preparing query parameters, and then we're gonna execute the query so we can start scrolling through the query result and retrieve values from the result set. And finally, we're gonna return the result and the list of journal entries. These are low-level data access tasks, and we as application engineers, we are more interested in business problems that requires this data access. What we'd like to write is code that saves and retrieve instances of our classes, relieving us of these low-level tasks. And basically, that's what an ORM is. Using object modeling instead of relational modeling is every developer's dream, but trust me, it's not that easy. And the comparison between the two words is called the paradigm mismatch. In the next section, we're gonna break this mismatch into several parts, which we're gonna explore and fully understand. Let's suppose we want to design and implement an online e-commerce application. We will need a class to represent user information and another class to represent users' billing details. The class diagram will be something like this. As you can see, a user has many billing details, and you can navigate relationships between the class in both directions. It means you can iterate through collections to get the list of billing details, or call a method to get the other side, which is the user. The class representing these entities may be extremely simple. As you can see, we'll have a user class with username, address, and as a set of billing details. In the other side, we'll have a billing details class with the account, bank name, and the user referring to. It's also easy to come up with a SQL schema designed for this case. As you can see, it's extremely simple. We're creating two tables, users and billing address, billing details, and we're creating a foreign key to refer to the username in the users table. Now, let's see what happens when you consider something a little more realistic. The paradigm mismatch will be visible when you add more entities and entity relationships to your application. In Java, you implement type inheritance using superclasses and subclasses. To illustrate why this can present a mismatch problem, let's add to your e-commerce application so that you now can accept not only bank account billing, but also credit and debit cards. The most natural way to reflect this change in the model is to use inheritance for the billing details superclass, along with several concrete subclasses, credit card, bank account, and so on. The most important question here is, what changes must you make to support this updated Java class structure? Actually, SQL database products don't generally implement table inheritance or even data type inheritance. We aren't finished with inheritance because as soon as we introduce this concept into the model, we have the possibility of polymorphism. Actually, the user class has an association to the Boolean JTL superclass. This is a polymorphic association. It means that at runtime, a user instance may reference an instance of any of the subclasses of Boolean JTLs. Similarly, you want to be able to write polymorphic queries that refer to the Boolean JTLs class and have the query return instances of its subclasses. The most obvious problem with the implementation we've done earlier is that we've designed an address as a simple string value. In most systems, it's necessary to store street, city, state, country, and zip code information separately. Of course, we could add these properties directly to the user class because it's highly likely that other classes in the system will also carry address information. It makes more sense to create an address class. So the question here is, should we also add an address table? The answer is no, because it's common to keep address information in the users table in individual columns. This design is likely to perform better because a table join isn't needed if you want to retrieve the user and address in a single query. The nicest solution may be to create a new SQL data type to represent addresses and to add a single column of that new type in the users table instead of several new columns. User-defined types support is one of a number of so-called object relational extensions to traditional SQL. This term alone is confusing because it means the database management system has or is supposed to support a sophisticated data type system, something you take for granted if somebody tells you a system that can handle data in a relational fashion. Unfortunately, UGG support is a somewhat obscure feature of most SQL DBMSs and certainly isn't portable between different products, so it's a bad idea to use it. The pragmatic solution for this problem is to use vendor-defined SQL types such as Boolean, numeric, and string data types. In the next videos, we will be discussing an optimal solution using Hibernate and JPA. In a nutshell, object relational mapping is the automated and transparent persistence of object in a Java application to the tables in a SQL database using metadata that describes the mapping between the classes of the application and the schema of the SQL database. In essence, ORM works by transforming data from one representation to another. So the difference between JPA and Hibernate is that JPA is a set of interfaces and it's a specification. So JPA defines a facility for specifying mapping metadata. It means how persistence classes and their properties relate to the database schema. Otherwise, it defines a language and APIs for specifying queries that refer to the classes and properties of classes. It's what we call the JPQL, Java Persistence Query Language, and it looks similar to SQL, it's just we're gonna use object instead of normal SQL schema. Otherwise, JPA defines also an APIs for performing basic root operations on instances of persistence classes. Hibernate is just an implementation of JPA and of all of its interfaces, and it supports all of the standardized mapping queries and programming interfaces. So that's it for this video. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.